Hi, this is Dr. Barron, and my molecule is sucralose. You may have heard of sucralose as Splenda, and in fact, the next time that you are needing to add sugar to a coffee or to any other beverage where you would like it to taste a lot more sweet, you might see Splenda as an option as opposed to real sugar. Now, sucralose, which is the more familiar chemical name for this molecule, was first discovered in 1976 and was approved for use in Canada actually in 1991. The USDA, particularly the FDA, approved sucralose as a non-nutritive sweetener in 1998 and as a general purpose sweetener in 1999. Now it's actually available in 80 countries and is used worldwide in over 4,000 commercial products such as no sugar added fruit, diet soft drinks, and reduced sugar juices. So sucralose has had a huge impact because it is replacing sugar and not adding calories to drinks and foods because it is not metabolized. And I'll talk more about how it is able to do that in this next slide. So the structure of sucralose is the key to how it replaces sugar and then is not metabolized and used to generate energy within the body, which is actually the main reason it's added to foods or you would want to add it. Sucralose replaces three hydroxyl functional groups on sucrose with halogens. So if you can see on the structural formula to the left, you'll see circled in blue three OHs. Those oxygen and hydrogen atoms, which are bonded to the outside of sucrose, are referred to as hydroxyl functional groups. Functional groups are the features of molecules that give rise to how that molecule behaves. So sucrose is what we often think of when we hear the word sugar. And of course, we Americans have a huge appetite for sweet beverages and sweet baked goods and a variety of other products that taste sweet. The problem is that these products, and particularly the sugar content in these products, allows us to consume far too many calories. And those calories really do change our bodies in a lot of ways. Unused energy, of course, gets stored as fat, and there's a lot of science behind how this happens. So what sucralose is a molecule which you can see on the right, replaces the hydroxyl groups with chlorine atoms. And it's these chlorine atoms that change the function of the molecule, which was originally sucrose. And that function is that it generates energy in the body. Let's take a look at how that's done. Sucrose's function in the body is particularly, it gets broken down first into two smaller molecules. It gets broken down into glucose and fructose. And glucose in particular, when combined with oxygen, which is the whole reason we breathe, results in the production of carbon dioxide, water, and energy, which the molecule that's used for energy purposes in our body is ATP. So sucrose's function is critical in our body because when we eat sucrose, it gets broken down into glucose. And glucose is what really drives our bodies by producing the molecule that's needed for us to live and generate the energy in our body. And this chemical process is called cellular respiration. Now, going back to the previous slide, sucralose, because it has those chlorine atoms on the outside, the molecule cannot be metabolized in the process of cellular respiration, where it cannot be broken down into glucose and fructose, and then the glucose there's no glucose to generate ATP, which is what's used to drive our bodies and cellular functions. Now what I'm going to do is I'm going to click play on a documentary that I'd like you to see about how sucralose has really impacted my life in particular and the lives of others in the world around us. Uh, and I would love for you to ask questions after the documentary about our molecule. Thank you.